Net weight filling and volumetric filling are similar in concept and definitely have the same end goals, but with a few key differences. So volumetric filling at its core is filling by volume, so filling by space. And then the way that you adjust for fill tolerances is making adjustments to your volumetric filling vessel, whether that be a piston or time on a time gravity pump or pump pulses. You're going to be adjusting per fill station your volumetric device to achieve fill accuracy. Now, typically the way that I think about it with the net weight filler is you add a little cost to the fill hardware by removing a step to your volumetric filling process. So in a net weight filler, you're filling on a scale to a known fill set point. There's no adjustment there. You're gonna hit plus or minus 0.5% your fill target every time. On a volumetric filler, because you're filling by area, the way that you're going to typically verify that you're hitting your fill tolerances is to go ahead and, well, you can check weigh on the line or remove bottles at the filler, set them on a scale, make sure that you're in tolerance consistently. So we're just removing that step. There's downtime there. You're still buying the scale, and then you're making micro adjustments. So during a changeover, you might, burn anywhere from a single cycle of bottles to 5 or 10 cycles, trying to get those fill volumes dialed in. So the biggest benefit to the net weight filling, in our opinion, is your over the time yield loss recapture, so you're not giving it away. And then just from a maintenance standpoint, you are really decreasing the changeover process, and so there's downtime costs there. And then another thing is that for maintenance, the actual liquid handling devices on the net weight filler are very simple. We have some kind of pump upstream of our wetted parts, and then you basically have an inlet manifold with a few valves and a hose feeding a nozzle with a bottom closed valve. All of those minimal mechanical parts. There's no pump device or piston, no seals in there to maintain. Everything is a sanitary tri-clamp fixture, off the shelf available. So your actual maintenance for your critical part of the filler, which is your fluid handling from your holding tanks into the jug, are incredibly simplified, easy to maintain, and can be changed out more or less on the fly should there be a mechanical failure in that process. In that way, your long-term costs between fillers can be greatly reduced because typically on a volumetric filler, you may have more fill heads on a volumetric filler. Typical would be in the 6 to 12 fill head range, and each of those stations will have some sort of pumping device that is typically the highest cost componentry on that filler. For us, each portion, there's a lot of hardware on a net weight filler, and then the scales are underneath the filler, but all of your liquid control devices are readily available off the shelf hardware that over time, there's minimal cost involved in maintaining them, and there's no high cost replacement parts on the whole thing. So once your machine is paid for itself, that initial capital investment on the hardware, including the scales, maintenance costs are relatively low because it's all commonly available low cost componentry.